Welcome to tutorial number 16, graphing quads in standard form. So before we go straight to the notes, I want us to make some observations which will help to make this lesson be a lot easier. So when we're looking at a typical quadratic, this graph of a quadratic, we notice some things. First of all, we notice that every graph of a quadratic, every parabola, that's what they're called, has a vertex. And we also notice that if we drew a vertical line straight through that vertex, we split the quadratic in half. And what that means is that the quadratic is symmetrical. The left side, it follows the same pattern as the right side. In fact, this vertical line that we just drew is called the axis of symmetry. Okay? You don't have to spell it. I just want you to know that that's what that line is called. And so two things so far. One, when we graph quadratics, knowing what the vertex is important. Two, drawing our axis of symmetry gives us a shortcut to finding the points. For instance, if we were going to make a table to find our points, watch. If we go over one side from the vertex over one to the right side, we're at 0 for x. And we can see in this graph that when x is 0, y is 3. And also, because it's symmetrical, if we move 1 to the left from this vertex, when x is equal to -2, y is also right there at 3. So the really cool thing is that when we're going to make our tables to graph our quadratics, we're only going to do one of these and then use the knowledge that a quadratic is symmetrical about the axis of symmetry. So we won't have to do this one. We're going to cut our work in half. Do you like that? And so because we're going to be focused on trying to get 5 points, the vertex and then 2 sets of points, we're only going to have to actually do another point, and that is if we already did 1 to the right of the vertex, we would look at 2 to the right of the vertex, which is when x is equal to 1. So in this case, when x is equal to 1, y is 6. If we went 2 paces in the direction of the left of the vertex, we would see that y, so let's see, that would mean that x is equal to -3 and y is also 6. Once again, we're not going to do that one when we graph. All right, so those are the 3 things that we're going to base our graphing quadratics on. All right, so the first thing is we're looking at this function, and we're using the f of x, which once again, this would be the same as y equals -x squared plus 4x, but the f of x we're going to use to our advantage in just a second because it's actually more usable than the y. It's more flexible. All right, so remember how I said the first thing that every quadratic graph has is a vertex? Well, the cool thing is that there's actually a formula to find the vertex. We can always find the vertex by finding -b over 2a. And so just to remind ourselves, remember when we did the quadratic formula, of course, this was our a, the number in front of the x squared. Because I just see a negative, I have to remind myself that's really a -1. So my a is -1. My b is always going to be my coefficient in front of the x, so that's 4, and that's all I need. So to find the x part of my vertex, I do -b, which is -4 over 2a, so 2 times -1. You either do that in your head and get a 2, or you can go ahead and pick up your calculator either way. All right, so what does that mean? That means that for my vertex, I just found the x part of my vertex. Now we know that a point has to have both an x and a y component to it, right? And so this is where we're going to use this whole idea of f of x being much cooler than just y. So what I want to know is, hey, what is the value of y when x is 2? So I'm going to write f of 2 because that's exactly what it says. Let's find the value of this function f when x is equal to 2. So all I'm going to do is I'm going to look at this equation and I'm going to plug in 2 wherever I see x. And so either I'm going to pick up my calculator or I'm going to say, what, this is 8 minus 4, so that's 4. Voila, that is my y part of the vertex. And so my vertex is 2, 4. So I want you to know that we're going to start, when we're graphing in standard form, We are going to start with finding the vertex. We are going to use this formula to find the x part of our vertex, which we did, and we use that formula to find that 2. And then we're going to plug in the 2 for x to find f of 2, which is just a fancy way of saying, hey, what's y when x is equal to 2? And then after we do that, the second thing we're going to do is we're going to plot the vertex. So a lot of writing, I know, just to find the vertex. It'll get easier. So here we go. Let's plot that point. It's over 2, up 4, 1, 2, 3, 4. There's our vertex. So this first thing, this whole big thing we just did was step 1. Okay, find and plot the vertex. Step 2 is probably our easiest thing we're going to do. And step 2 is draw axis of symmetry. So here we go. We're going to look at our vertex and we're going to remind ourselves to draw a vertical line through that vertex because it reminds us that this quadratic is symmetrical. All right, and then our step 3, I'm going to actually do on the graph. So let's see. Let's find a really good color. Not turquoise, that'd be hard to see. Let's do that magenta again that I like. Okay, so we're going to make a table and we're going to think really smart. We're going to think, if my vertex is on 2 for x, I'm wondering what happens as I look to the right of 2 and to the left of 2. So I could either plug into my table either 1 or 3. Does it matter? No. Let's go ahead and just plug in 1 because 1's pretty easy. So what I'm going to find for y, I'm going to find f of 1. So that just means plug 1 in every time you see the x. And then either pick up your calculator and put this part into the calculator or do it in your head, right? -1 plus 4 is 3. Okay, once again, we talked about symmetry. So the point 1, 3 is right here. I don't need to put in my table, hey, I wonder what y is when x is 3. I already know. It's symmetrical on both sides. So there, I'm almost done because now all I need is another point and to use my knowledge of symmetry. And so here we go. I already know what happens with y when we move 1 away from the vertex, from the x being 2. How about if we move 2 away? So now we're looking at, hey, I wonder what y is when x is equal to 4 or x is equal to 0. I could plug 4 into my table or 0. I'm just going to do 0 just because, I don't know, 0 seems easier. So let's go ahead and find what the value of the function is when f is equal to 0, which means that every time I see x, I'm going to plug in a 0. And I'm going to either pick up my calculator or just say, oh, we just got a bunch of zeros here, right? So let me get rid of this arrow to the left and to the right. And so what that means is that when x is equal to 0, y is equal to 0. And because of symmetry around the axis of symmetry, I also know that when x is equal to 4, y is equal to 0. And then you know what we have left? Just to go ahead and make our sketch look nice and curvy. We know it should look like a U. In this case, it's an upside down U. And we're going to try our best to include all 5 points that we just found. All right, let's do this again. So when we see quadratics that have more than one term with an x in it, we know that we're going to use standard form. There is another way to graph, and we'll do that next tutorial. All right, so here we go. We've got a new quadratic. We're going to use x equals -b over 2a to find the vertex. I'm going to scooch up a little bit. Let's see, I'm going to need some more room, or I'm going to have to write smaller. So here we go. Step 1 is, ooh, that 2a just kind of was on its own, wasn't it? All right, so step 1 is to find the vertex. So the first thing I'm going to do is say, well, a equals 1 and b equals -3. I got that from there and there. So x is equal to -b, so that's -3 over 2 times a. I can pick up my calculator, or I can figure out this is, oh no, it's 3 over 2, so it's 1.5. You know what? That seems awful. but it's just a decimal. We can deal with it, right? So now we know that our vertex is going to have the x value of 1.5. Now we have to find the y value so that we can plot our vertex. All right, so let's go ahead and find what f of 1.5 is. We're going to plug in, let's see, 1.5 squared minus 3 times 1.5 minus 10. And I'm going to have to pause this video because I do not have a calculator where I'm at. So let's see if I can pause it. Okay, and so I'm back from pausing, and I got my calculator, and I figured out that this vertex is not going to be pretty, but that's okay. We can handle it, right? So there we go. It's negative 12.25, and so I'm going to just do my best when graphing it, right? That's all we can do. The first thing that we notice is that our graph stops at negative 10, so let's go ahead and extend it and give ourselves a negative 11 and a negative 12, and we know that 1.5 is not going to be fun either, but you know what? We can do this. We can do this. So let's see. 1.5, that means I'm going to go over 1.5, and then I'm going to go down. I'm going to go a little bit past negative 12, and there's my vertex. All right, so we plotted our vertex, and now we are going to draw our line of symmetry, our axis of symmetry. So our axis of symmetry should go through where x is equal to 1.5, right? There we go. All right, and now when we move to the table, we're going to get rid of all this mess because we're going to pick good points, right? So instead of going, my closest that I'm going to look at is going to the left a half, and I end up with x being 1. So I'm going to find f of 1. Let me put this down. I'm going to find f of 1. So f of 1 means that I'm plugging 1 in anytime I see an x. So I'm either going to pick up my calculator, or I'm going to see that this is, let's see, 1 minus 3 is negative 2, minus 10 is negative 12. So I'm going to go to 1. I'm also going to get rid of this part. Okay, I'm going to go over 1, and I'm going to go down negative 12. And I also know if I go over to the x is equal to 2, I'm also going to be down at negative 12. All right, I wonder what happens when x is equal to 0. So I'm going to plug 0 in, and I'm going to get, if I find f of 0, that means plugging in 0 every time I see x, and that gives me a negative 10. So I'm going to be at negative 10, and I also know if at 0 I'm going to, my y value is going to be at negative 10, then at 3, my y value is also going to be at negative 10. All right, this seemed like a mess. I am going to go ahead and connect these in a very curvy way. Let me get rid of, let's see, hold on just 1 second. Let me get rid of this because I'm going to do something else. All right, so let's go ahead and connect this in a very curvy way. Let's see, we're going to come through. Okay. Not the best, but you know what? It's not bad. Now, I'm going to let you in on a secret. There is another way to graph quadratics in standard form. And if you're really good at factoring, you might want to use this. So if not, move on. Just you did this problem. But if you're curious as to a second way, I'm going to start over again real quickly. And the one thing that you can do is you can say, hey, I wonder if I went ahead and set y equal to 0 and factored. Once again, I'm talking to those of you that are good at factoring, and set each of those factors equal to 0 and solved for x, look what I get. I would get that when x equals 5 and when x equals negative 2, y equals 0, because, right, I set y equal to 0. If I wrote these points in a table, it would look like this. When x is 5, y is 0. When x is negative 2, y is 0. And so what I found are the x-intercepts, right? So there they are. There's one, and there's the other one. And then what I'd have to do is I'd have to play a game, and I'd say, well, knowing that quadratics are symmetrical, I'd have to find the midpoint between -2 and 5. So that means I could either, use my fingers. You can't see them. Sorry, they're not being recorded. But I could go in one this way, one that way. One this way, one that way, one this way, one that way, and then realize, boop, right here is my midpoint. I could do that, or I could just say in my calculator, -2 plus 5 equals 3. 3 divided by 2 equals 1.5, right? That's how we find the midpoint. And so once I did that, I would say, oh, so the midpoint, the axis of symmetry, is when x is equal to 1.5. And all I need to do is find what f of 1.5 is equal to, which we already did that work. We know it was -12.25. And there we go. I would already have found my vertex. If you like this method, do it. If you don't like it, at least you know the standard form way, all right? It's going to get you to the same graph. So those of you that feel like challenging yourself, you can always try this way. All right, and our last problem. So on problem 2, identify where the graph will have a y value of 8. Write your solution as an ordered pair. So I'm going to try to make this problem as easy as possible. Here's the deal. When we look back at the graph, we see y is 8 way up here. Okay, this is where y is 8. We could guess, we see that this graph is there, and if we extend it this way, the graph's there. We could kind of guess where the graph might be, but I can't really tell. I didn't do that great of a graph, and neither did you. Okay, it wasn't just me. Anyways, but they're basically saying there are going to be 2 points where the y value is an 8. Okay, we don't know the x value of one of those points, and we don't know the x value of the other point. But gosh darn it, we do know the y value is going to be 8. So I suggest that's how you start this problem. Knowing half of the answer already, isn't that great? There are going to be 2 points, and both of those points have a y value of 8. All right, so let's go ahead. I think we're going to need magenta for this one. All right, so let's go ahead. It says we're going to have a y value of 8. Well, funny, I see a y right over here in our equation. So that means we're going to take 8 and we're going to plug it in for y. And I don't know about you, but when I see this, I have some options, right? Well, first of all, my first option is I got to get rid of that 8. I can't really do anything to solve when I have, obviously I can't use the square root method because there's more than one term with an x, right? We have an x squared and an x. But the first thing I have to do is get everything over to one side so that the other side's equal to 0. And then I have a choice, either factor or use quadratic formula. Or complete the square. And you know what? Factoring is going to be the easiest one, right? So let's go ahead and factor. Think of 2 numbers that multiply to equal -18, but add to equal -3. How about -6 and +3? So -6 times 3 is -18. -6 plus 3 is -3. That's awesome. Let's go ahead and set both of those factors. I'm not sure why I'm doing the parentheses again. Let's set both of those factors equal to 0. And let's solve for x. So we're going to add 6 to both sides. We get x is equal to 6. We're going to subtract 3 from both sides, so x is equal to -3. So hey, remember how we knew that our answer consisted of 2 points? Well, now we know that the x value for one is 6, and the x value for the other is -3. So there we have it. At 6, 8, and at -3, 8, that's where the function has the height of 8. So let's see if that's true. At 6 and -3, let's just go back and see if we were even close. So at 6, 8, yeah, I could believe that, right? 6 and 8, we were close. And -3 and 8, okay. So the graph went a little bit wider than now that we see this, we can probably draw a better graph. And you know what? Maybe your graph was better. Maybe you could look at your graph and see those too. Regardless, on the test, when it asks us this type of questions, we need to solve it algebraically. All right, that's it. Woo! Make sure you practice, ask questions, and check your answers. Thanks for joining me.